This is a correction of the practical session Machine Learning with Orange. So the first question we was asked to build this model here. And the question is which animals are misclassified? So we can see in the confusion matrix that 3 animals, 2 here and 1 here, were misclassified. One invertebrate was classified as a reptile, and 2 mammals were classified as a reptile. So to see which animal is it, we first select both errors. Okay, and now we send the output of the confusion matrix, the 3 animals which were selected. We send this to a data table. And if we look at the data table, we can see that the dolphin, which is a mammal, was classified by the naive Bayes as a reptile. And the porpoise, which is another kind of, it's a mammal too, it's a kind of dolphin, was classified as a reptile too. And for the scorpion, which is an invertebrate, was classified as a reptile. So now it is asked to add a logistic regression. So we just add logistic regression. So now in the prediction, we have for each animals with their characteristics here. For example, we have this antelope, which is a mammal. We have the fact that it has a hair. It's true. No fissures. No, it doesn't give eggs, and so on. All the characteristics of this animal. And for logistic regression, predicts that it is a mammal. And it is the same for Bayes. Okay, but if we have a look at the dolphin, yes, here, we see that the naive Bayes predict it is a reptile, but it is a mammal, and the logistic regression doesn't give us an error because it predicts that it is a mammal. So we can confirm this with a confusion matrix. For Bayes, naive Bayes, we have 3 errors. But for logistic regressions, we have no errors. All the animals are on the diagonal. It means that every animal were predicted with a good family. So now we will add an animal CSV file. So we just have to download this file from the website. Animal, which is here. We have downloaded here. So I will add a file and upload the animal. So animal is in downloaded files. Okay. So this is no, we will see this with a data table. It's better. So we can see that we have 4 animals: tiger, sperm whales, which is just like a whale, very big whale, shark, and eagle. And we have all their characteristics, but we don't have the family. We don't have the fact that a tiger is a mammal, for example. That's what the model will have to guess, to predict. So we will use prediction of the model. So to do this, we have to use this new diagram. So connect the output of the file to the prediction. Okay, and now we can see the output of the prediction. we can see that the tiger was predicted as a mammal for both models, and it's true, the tiger is a mammal. The shark was predicted as a fish by the two models, it's true, a shark is a fish. Eagle was predicted as a bird by the two models, and it's true because the eagle is a bird. But the sperm whale, which is a big whale, was predicted as a reptile by the naive Bayes, which is false, and predicted as a mammal, which is true by the logistic regression. So the answer to the question here is the sperm whale, which was not predicted with a good class by the model naive Bayes. So why do we have errors with marine mammals, sperm whale and porpoise and the dolphin? 3 errors involve the mammals, but marine mammals. Maybe the explanation may be that because for all the other mammals like lion, tiger, antelope, and so on, all have some characteristics here. All the mammals have hair, it means fur. Of course, all produce milk because it's the main characteristic for mammals, but they have legs too, a number of legs, legs here. All not marine mammals, but the mammals which lives on the ground, they all have legs, on 4 legs. And because we have a lot of mammals which live on the ground, they all have 4 legs and they all have furs. But, of course, the marine mammals, they don't have legs and they don't have fur. So this is the reason why the system, the naive Bayes algorithm, finished to learn that if an animal has no legs and no fur, it's not a mammal, it's a reptile, for example. So how can we change this? We can change this in providing in the zoo file, in this file here, which has 101 examples of animals. We can provide more examples of marine mammals. And doing this, the naive Bayes model will forget to learn that a mammal is associated to 4 legs. It will only focus on the fact that all mammals have milk. It's the only characteristic which must be used to say that an animal is a mammal. Now for this new exercise, we will use a new file, a file which name is housing.tab, and this file describes different houses, the characteristics, the features of different houses, and the price it has been sold. And the goal of the model is to predict the price, the sale price of this house. So if we have a look at the data, we have all these features. The crime, for example, is a crime rate by town. So we have this information here. So we have this information for 506 houses. And for each houses with these characteristics, we have the real price, the price at which this house has been sold. And this is what our model has to predict. So, contrary to the previous exercise, where we do a classification, we try to find in which class an animal belongs, if it belongs to mammals, to reptile, or to bird. Here we have to predict a continuous value, the price, and this is a regression problem. So we will use a test and score and use three different models, in order to compare these three models. So a random forest, linear regression, and neural network. And all these models are trained with data from the 506 houses from this data file. So if we have a look at the model, at the score, the metrics of this model, we have the MSE, mean square error, or the remote mean square error. All these metrics should be the smallest as possible. So the small, to compare three models here, for example, we classify this, and because random forest has the smallest value for MSE and the smallest value for RMSE, it means that this model is better than these other models. And the worst model is a neural network for this case, for this problem. So for each model, we can see what each model predicts as a price. We just have to double click here on the data table. So for each 506 houses, we can see that for this first house, which with these characteristics, these features, and the real price is 24,000 euro or dollar, I think. For this case, the best prediction was done by the random forest, which has only $3,000 of difference. But sometimes, maybe for this one, yes, for this one, I think it is the case. Yes, no. Let's say for I try to find. Yes, for example, for this one, random forest has a bad score if we compare to the linear regression. Linear regression is closer to its prediction is better to predict for the real price here. But on the average, the best model is a random forest, as we have seen here with the metrics.